A Brief History of Time, From the Big Bang to Black Holes by Stephen Hawking. A brief history of time is written in very simple terms, have been penned for the common man's understanding. The prerequisite to understand this book is to have a basic understanding of the physics of the universe. This book was first published in 1988. Hawking wrote the book for the reader who have no prior knowledge of the universe. This book answers some of the questions like, where did we come from? Why is the universe the way it is? Was there the beginning of time? From this book you can learn that the universe is expanding between 5 to 10% every 1,000 million years. This book also contains information to help us understand science view of how just our universe might have been put together. Hawking's use of analogies, of visualization of space and time to make Stephen Hawking tried to answer basic questions such as, was there a beginning of time? Is there an end to the universe? What are similarities of black holes, singularity and big crunch? Is the universe infinite or does it have boundaries? What are the effects of the critical values of the universe density on its rates of expansion? What is the role of God in the creation of the universe and how it can be evaluated by the entropic principle? Did God create laws of quantum mechanics and theory of relativity and let it evolve itself without leaving an option for him to intervene? How did God choose an initial state or configuration of the universe? What were the boundary conditions at the beginning of time? Stephen Hawking also reviews the literature of Newton's law of gravitational force, Einstein's theory of relativity, and quantum mechanics. Stephen Hawking also tries to understand electromagnetic force, the strong and weak nuclear forces, the gravitational force by one unified field theory. This book also explains from the Big Bang to where future theories come into play. How to unify two contrary, maybe even contradictory theories about how the world works. Quantum theory and relativity theory. The former works well on the microscopic level, while the latter works well on the macroscopic level. But the two are at odds when combined. How could this be? Dr. Hawking mentioned entropy, which is equal to the disorder, and he uses it as a synonym for disorder. This book tells us that there are great minds that do understand how and why our universe works. The Big Bang and black holes have become parts of our common vocabulary now. Stephen Hawking updated this book with a new chapter on wormholes and time travel. Even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science of constructing a mathematical model cannot answer the question of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? He also wrote, the universe does not allow perfection. If time travel is possible, where are the tourists from the future? A well-known scientist, some say it was Bertrand Russell, once gave a public lecture on astronomy. He described how the Earth orbits around the Sun and how the Sun in turn orbits around the center of a vast collection of stars called our galaxy. At the end of lecture, a little old lady at the back of the room got up and said, "What you have told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise. The scientist gave a superior smile before replying. What is the tortoise standing on? You are a very clever young man, very clever, said the old lady. But it turtles all the way down. The increase of disorder or entropy is what distinguishes the past from the future, giving a direction to time. If you remember every word in this book, your memory will have recorded about 2 million pieces of information. The order in your brain will have increased by about 2 million units. However, while you have been reading the book, you will have converted at least 1,000 calories of ordered energy in the form of food into disordered energy in the form of heat that you lose to the air around you by convection and sweat. This will increase the disorder of the universe by about 20 million units, or about 10 million times the increase in order in your brain. And that's if you remember everything in this book. He also wrote, God abhors a naked singularity. What did God do before he created the universe? The rate of progress is so rapid that what one learns at school or university is always a bit out of date. Only a few people can keep up with the rapidly advancing frontier of knowledge, and they have to devote their whole time to it and specialize in a small area. The rest of the population has little idea of the advances that are being made or the excitement they are generating. We find ourselves in a confusing world. We want to make sense of what we see around us and to ask, what is the nature of the universe? What is our place in it? And where did it and we come from? Why is it the way it is? Humans' deepest desire for knowledge is justification enough for our continuing quest. And our goal is nothing less than a complete description of the universe we live in. Here is a funny quote from the book. As we shall see, the concept of time has no meaning before the beginning of the universe. This was first pointed out by Saint Augustine when asked, what did God do before he created the universe? Augustine did not reply. He was preparing hell for people who asked such questions. Einstein never accepted that the universe was governed by chance. His feelings were summed up by his famous statement, God does not play dice. Hawkins also wrote, you cannot predict the future. A theory is a good theory if it satisfies two requirements. It must accurately describe a large class of observation on the basis of a model that contains only a few arbitrary elements, and it must make definite predictions about the result of future observations. Stephen wrote, I am just a child who has never grown up. I still keep asking these how and why questions. Occasionally, I find an answer. It is said that there is no such thing as free lunch, but the universe is the ultimate free lunch. Aristotle, unlike many other people of his time, thought that the earth was round. He came to his conclusion by observing lunar eclipses, where he thought were caused by the earth's round shadow. Early philosophers like Aristotle thought that the universe has existed forever, while theologians such as Saint Augustine believe it was created at a specific time. Saint Augustine also believed that time was a concept that was born with the creation of the universe. More than 1,000 years later, German philosopher Kant thought that time goes back forever. In 1929, astronomer Edwin Hubble discovered that galaxies are moving away from each other. Consequently, there was a time between 10 and 20 billions ago when they were all together in one singular extremely dense place. This discovery brought the concept of the beginning of the universe within the province of science. Today's scientists use two partial theories: Albert Einstein's general theory of relativity and quantum mechanics, to describe the working of the universe. Stephen Hawking talks about how the Aristotle theory of absolute space came to an end following the Newtonian theory that rest and motion can be the same state if an observer sees the event while at rest, or if he moves at the same speed as the event. Therefore, rest cannot be the standard position. Mass and energy are also related by the famous equation E is equal to mc square. So it will require infinite energy to get the speed of light. Black holes are stars that have collapsed into one small point. Black holes can be shaped differently. Some black holes are perfectly spherical like a ball. Other black holes bulge in the middle. Black holes will be spherical if they don't rotate. Black holes will bulge in the middle if they rotate. Black holes are difficult to find because they don't let out any light. They can be found when black holes suck in other stars. When black holes suck in other stars, the black hole lets out X-rays, which can be seen by telescopes. In Chapter 8, how the universe started and how it might end is discussed. Most scientists agree that the universe started in an expansion called the Big Bang. The model for this is called the hot Big Bang model. When the universe starts getting bigger, the thing inside of it also begins to get cooler. When the universe was first beginning, it was infinitely hot. The temperature of the universe cooled, and the thing inside the universe began to clump together. Hawking states that physics grows ever closer to accurately describe the laws governing the what of the universe, but also that it will take thinkers of many diverse disciplines to weigh on it the why of it. Regarding the universe and meaning, why was the universe so hot begin with? Why is the universe so uniform on large scale? Why did the universe start with so nearly the critical rate of expansion that separate models? One possible answer is that God chose the initial configuration for reasons we cannot hope to understand. This would certainly be in the power of an omnipotent being. But if he had started off in such an incomprehensible way, why did he choose to let it evolve according to laws we could understand? It's like monkeys hammering away on typewriters. Most of what they write is garbage, but very occasionally by pure chance they will type out one of the Shakespeare sonnets. There are two explanations for the extraordinary occurrence.